I welcome you all in the next video tutorial of pharmacognosy and phytochemistry 2, and we have started unit number 4, and in this video tutorial we are going to cover yet another important phytoconstituent, that is the dioxin. So digoxin, its industrial production, estimation and utilization. So let's start. So let me recall a bit. Yes, this is the plant that we are talking about, the Digitalis purpurea and Digitalis lanata. These two are the most frequently used species. Okay, and I hope you remember these two species. If you talk about our chemical constituent, that is the digoxin. So here it is. This is the digoxin. Preparations are also available in the market, and this is the chemical structure that you have to remember about this plant. Okay, and I hope you remember about the cardiac glycosides, because we know the cardiac glycosides are classified into, yes, cardinolides and bufadienolides. And what is the difference? Cardinolides are 5-membered lactone ring, O double bond O. This is lactone, this is 5-membered, so this is cardinolide. And what is bufadienolide? Yes, it contains 6-membered lactone ring. Okay, so I hope you remember about this difference also. So let's start our plant now from the. Okay, so this one is the about the cardiac glycosides that we are going to cover. So let's first recall a bit. This is digoxin obtained from the plant. Yes, Digitalis purpurea, dried leaves of. So always remember the part used is the leaf. Although flowers are also used commercially, but the flowers are generally used for the ornamental purpose, whereas the leaf is used for a medicinal purpose. Yes, Digitalis purpurea, Digitalis lanata, scrofulariaceae is the family. We have already completed this portion also in the previous video, so I request you to watch the videos. It contains purpurea glycoside A, purpurea glycoside B, and again it will, upon hydrolysis, suppose for purpurea glycoside, upon hydrolysis it will give digoxin plus glucose. And I hope you remember about the glycoside. So what are glycosides? Yes, they comprise of two major parts. First is the glycone and other one is the aglycone part, sugar part and non-sugar part. Okay, and the sugar part is generally we are focusing upon the non-sugar part, that is the aglycone part, because aglycone part is responsible for its pharmacological action. Okay, this is the structure of the digoxin. So you have to remember this structure, you have to recall this structure. This is very, very important. So let's start directly the extraction part or the production part. First of all, we will take leaves, okay, because we will obtain digoxin from the leaf sample. Then it was extracted with 50% ethanol. So generally we will use oxide apparatus over here also. Okay, but we have to maintain the temperature limit, because temperature limit in this case particularly should not exceed 45 to 50 degrees Celsius, because digoxin is very thermolabile compound. So we have to maintain the temperature limit, otherwise it will deteriorate our digoxin compound. So then extracted with ethanol, and we obtain the filtrate, and in the filtrate you have to add lead acetate solution, because we know plant is a mixture of phytoconstituent. So as to remove the other compounds like tannins, we will add less acetate solution into it. So what will happen? Impurities will precipitate out. Okay, we have to remove the impurities with the help of lead acetate solution. Next step is we have to subject to the centrifugation in the centrifuge to remove the precipitate. So after removing of the precipitate, we have our cardiac glycoside which is present in this supernatant liquid. Then we will use an organic solvent like chloroform to collect our cardiac glycosides, and then it is further purified by chromatography, or you can also go for column chromatography over here, and finally you will obtain digoxin. I am repeating a bit again. It is very simple procedure. First of all, leaves are taken, extracted with ethanol, and for removal of the other materials like tannins, you have to add lead acetate solution. When you add lead acetate solution, what will happen? Precipitation will occur, and you have to remove this precipitation by centrifugation. You will use centrifuge. Okay, then cardiac glycoside, when you will centrifuge the particular filtrate, what you will see, the cardiac glycosides are present in this supernatant liquid. You will remove the precipitate and you will find the liquid which contain cardiac glycosides. And from this liquid, how will you isolate cardiac glycoside? You will use an organic solvent like chloroform. Okay, then you will further purify it using the column chromatography or other chromatography technique, and finally you will obtain digoxin as your pure compound. Okay. So this is again method number 2. So let's see this method again. This is method 1 that we have completed. This is method number 2. So again we will take powder of the leaf, 25 grams. Suppose over here it is written, and it was extracted with pet ether so as to remove fats. Oh, okay, defatting is done. You will dry the drug. Then again you will extract this same drug with 50% methanol for 24 hours, and you will collect the methanolic extract, and you will dry it under particular, distill the methanolic extract, or you can say concentrate it under vacuum. Then you will treat this with carbon tetrachloride. Okay, and you will collect this carbon tetrachloride layer, and you will evaporate to obtain digoxin, which is further purified by column chromatography. Let me recall a bit. Again, this is very simple. First of all, leaf is taken, extracted with pet ether to remove the fats, and we know fats are non-polar. So like for the dissolving of the fats, we will use a non-polar organic solvent like pet ether or hexane. So this process is also known as defatting, removal of fats. So here you will take your drug, you will remove the fat or other non-polar materials which are present in the drug. Then you will take the same drug powder after drying, and you will treat this powder again with 50% methanol. You will do extraction with methanol. Okay, first of all you do defatting, then extraction with methanol, and you will collect methanolic extract. You will concentrate it basically and add carbon tetrachloride. Just single step. Very simple. Then you will collect this carbon tetrachloride layer and evaporate it. It is further purified by column chromatography, and finally you will obtain your compound as a digoxin. Okay, so I think these two methods are sufficient. This is method number 1, in which we will use lead acetate solution to remove impurities, and over here we are using pet ether, first step, and second is the carbon tetrachloride. Again, this is very simple. 2-step method is there. Okay, so for its identification, there are different chemical tests like Legal test or Baljet test are there. Then identification by Keller-Kelanin test. So I hope you remember about these tests. Next, main important test is the identification test by TLC method. So we know in TLC what we need: stationary phase and mobile phase. But what is the stationary phase over here? Pre-coated silica gel. And what is the mobile phase? Benzene ethanol. Sample, of course, you will take a plant extract that is present in the leaf, digoxin. Okay, detecting reagent, anisaldehyde or perchloric acid is also used, and you will done UV detection at 350 nanometer. You will observe blue spot. This is the TLC method number 2, in which we are using mobile phase, ethyl acetate, methanol and water, 81:11:8 ratio. Again, detection by Caddy reagent, and you will observe again blue spot. This is another important method. This is a colorimetric estimation that you have to remember, and we will treat our extract with 3,5-dinitrobenzoic acid plus benzyl trimethyl ammonium hydroxide, and you will ultimately form bluish red color, and it is done. You will observe under UV at 550 nanometer. So I hope you remember about this method, because we have already covered the colorimetric estimation in diosgenin. Okay, the extract is taken. You will add these two chemicals, 3,5-dinitrobenzoic acid plus benzyl trimethyl ammonium hydroxide. You will obtain this color, that is bluish red, and finally observe under UV, that is 550 nanometer, or colorimetrically measured at 550 nanometer. This is the assay of digoxin, that is IP method. So this is, I think, more than sufficient colorimetric determination. Yes, about the uses we know. Cardiac glycoside, it is a cardiac tonic, so employed in the treatment of coronary heart failure. It is also used as a diuretic in cardiac edema. So very, very important drug. So I think this is about the digoxin. So yes, we have